We want to explore the concept of transformation. And transformation is said to be a geometric transformation involves the movement of an object from one position to another on a plane. Now, this movement is accompanied by a change in either position, orientation, shape, or even size. Now, some examples of transformations that we will look at in CSEC are translation, reflection, rotation, and enlargement. There are more, but these are the few we will be focusing on. And in this video, I want to look at the first one, which is translation. Now, translation is the movement along a straight line in a fixed direction. Now, translation is said to be one of the simpler or one of the simplest of the transformations. In this one, the object is just moving along a straight line. For example, we have this triangle here, and if you want to perform a translation in this triangle will move from this position and just shift along a straight line. It will not change in size or it will not rotate. It will just shift on a straight line. So what we want to look at now is how do we describe this movement, which is translation. So there are two things that we use to describe the movement. Firstly, we describe it using the direction of the movement and also the distance that the object traveled. And this is done using a translation vector, and it's very simple. So in this example here, we have the object, which is this here. And we want to describe this movement from here to here. So what we do, we can take any point. For example, you see we have the triangle has points A, B, and C. And then after we finish moving this triangle, it now has points A prime, B prime, and C prime. We use prime to represent the image, which is the object after it would have moved. So how can we describe this movement? So we can take any point on the triangle, let's say point C, and we can see how many times it moves horizontally and then vertically to meet to the prime, the C prime. So we can count this. So we see move 1, 2, 3, 4 times in the right, and then we move 1, 2, 3 times up. So this movement can be described using the vector. We move 1, 2, 3, 4, positive 4, and 1, 2, 3, and positive 3. And this will tell you that it moved 4 times to the right and 3 times up. And that is how you describe a translation. So let's say now we are given a question. The question says P is mapped onto P prime. The point P is mapped onto P prime, which is the image, under the translation 2, 3. Determine the coordinates of P prime, which is the image of P under the translation. Now there's a simple formula that we use to find the image, and that is P, which is the object, plus the translation vector will give you P prime. So we know P is 3, 1, and we can rewrite that as a column vector, 3, 1, plus the translation vector, which is 2, 3. When we add this together, we will get the image, which is P prime. So this will be 2 plus 3. That would give you 5, and 2 and 1 plus 3 would give you 4. So the coordinates of the image would be 5, 4. And we have another question. The point P is mapped onto A prime, which is 2, 3, by a translation vector, negative 1, 4. Find the coordinates of A. So once again, just now we learned the formula to describe this movement. It's the object, in this case it would be A, plus the translation vector, and that would give you the image, which is A prime. So in this case, we want to find the point A. So A would be A plus the translation vector, which is negative 1, 4, is equal to the image, which is 2, 3. So we can just make this the subject, or we could have made this the subject here, and this would be, since we want to find A, this would be A is equal to a prime minus t. So this will be a is equal to a prime, which is 2, 3, minus t, which is this here, which will be negative 1, 4. And we work this out. 2 minus negative 1, that is the same as 2 plus 1, that would give you 3. And 3 minus 4 would give you negative 1. So our answer is, the point is 3, negative 1.